Hello everyone, welcome back again. This is Dada. Last video we learned about the linear search algorithm, and in this video we are going to cover binary search algorithm using Java. First we will take a look at the definition, then the working of algorithm, and then we will cover a practical example of binary search algorithm with step by step. So this is a very simple definition of binary search algorithm. So it is a way to find a value in a sorted list. That means in order to perform the binary search algorithm, we need to make sure that we have an array or list which is in sorted order. So it checks the middle item first and then decides whether to search in the left or right half, cutting the search range in half each time or each iteration. Let's have a quick look at the working of algorithm. So we have actually 4 steps. Compare x, which is our target value, with the middle element. If it matches, we return the index of mid element. If x, which is our target value, is greater than the middle element, we'll start searching on the right half. And if it is smaller than the middle element, we'll start searching on the left half. So let's start with our array. The goal is to find the target value 41 using binary search. So here is how the binary search works. First we set 2 pointers, low and high. Low starts with the first element at 0 and high starts with the last element as 6. Next we calculate the middle index using the formula low plus high divided by 2. So let's go step by step. So let's calculate the middle. Low plus high divided by 2. So low is 0 and high is 6. 0 plus 6 divided by 2 is 3. So now we have our middle is 3, and on third index we have element available 37. Let's start comparing our target value with the middle element. So since 41 our target value is greater than 37, that means our target value is available on the right side of an array. Okay, so then we are sure, then we can discard the left side of an array. So in that case, in the next iteration we have to start searching for our target value in the right side of the array. So for that we have to update the low to middle plus 1. So middle is 3 and plus 1, 3 plus 1 is equal to 4, and high will remain as 6. Okay, so now we have got low is equal to 4 and high remains same as 6. So 4 plus 6 divided by 2 becomes 5. Okay, so now middle is equal to 5, and on index 5 we have got element 49. Now let's start comparing. 41 is our target value and middle element is 49. That means target value is less than 49. So in that case we have to update the high to middle minus 1. Okay, so when our target value was greater than the middle of the element, we updated the low as middle plus 1. And now when we have our target value is less than the middle of the element, so we are updating the high to middle minus 1. So middle being 5, 5 minus 1 is equal to 4. Okay, so high remained as 4 now, and now we haven't even updated the low, so low will remain as 4 on this point. So in the iteration number 3 we didn't do anything with the low, so low was 4 in the last iteration as well, but for the high we updated. So now high we have as 4. So 4 plus 4 is equal to 8, and 8 divided by 2 we have again index 4. So middle is 4, and on the 4th index we have 41 itself, which is our target value. So that means 41 is equal to target value is equal to the middle of the element 41. That means this is the match and the target value has been found at index 4. Now you see, in this binary search we search our element within 3 iteration, and let's say if it was the linear search algorithm, it should have been found the element on the fifth iteration. That means 0, the first, second, third, fourth, fifth. So you see how faster is the binary search in comparison to the linear search. So that was the understanding and working of binary search algorithm. Now let's head into the NetBeans. Let's start with the main method. Static void main string args, then initialize an array is equal to same element 03 05 17 37 41 49 and 73, and our target value which is 41. Okay, then simply call the binary search method, which we will provide implementation a bit later. So binary search will receive array and our target value. So if result is equal to -1, simply will print target, which is 41. Okay, not found, and then array. Okay, else target found in an array at index, which is result. Okay, it's clear here. Now we will go outside of the main method and initialize or create a binary search method, since this will only return the result, and so we have to provide the return type as integer and binary search, and it will receive an array. So int array and target value as an int. Okay, so this is function for binary search, and this is display the result, and call the binary search method of function, whichever you call. Okay, so here we have to initialize low as int. Low would be 0, that means very first index on element, and integer high is the last value of an array, so that would be as array dot length -1. Okay, so array's length is 1 2 3 4 5 6 7. So 7 minus 1 is 6, because index starts from the 0. Okay, while low is less than is equal to high, calculate the middle is low plus high divided by 2. Okay, now we almost have the initial setup. Low is 0, high is equal to array length -1, and we also have the middle. So now so this was calculating the middle index. Okay, now we can go ahead and check if the target is available at the middle. So if array middle is equal to target, then we simply return the middle. Okay, if not, then we will check if the target is greater, then we can ignore the first or left half an array. Okay, so if array at middle is less than the target, okay, then simply increase the lowest middle plus 1, so that we can start comparing the elements from the other half of an array. So that means it will start discarding the first part or first half of an array. We'll try to understand through the iteration. Okay, else, okay, if target is smaller, then ignore the right part of an array, or we can say the other part of an array, okay. And here we will high is equal to middle minus 1, okay. Now simply if the target value is not found, okay, if target value is not found, then we simply return is -1, okay. Simply run the program. You can see target 41 found in an array at 4 index, okay, 0 1 2 3 4, okay. Now let's go ahead with the iterations. So low is less than is equal to high. What is low? Is 0 is less than is equal to 6. That's correct, okay. Now we come down here, and middle is equal to low plus high, okay. So low plus high, that means 0 plus 6, okay, 0 plus 6 divided by 2, that will become as middle is equal to 3, okay. So on middle 3, what element do we have? Okay, we have 0 1 2 3, we have 37, okay. Then here it checks is 37 is equal to 41. That's incorrect, so this will not get executed, okay. Then it comes back here, it will check here is 37 less than 41. That's correct. Then this line will get executed, which means low is equal to middle plus 1, okay. So what is our middle? Our middle is 3, okay. Our middle is 3 here. Then low becomes is equal to 3 plus 1, it means 4, okay. Now we have updated value of low is 4, okay. So now it comes back to the initial line. So now is 4 less than is equal to 6. That's correct, okay. Now we remove all this. Now we have updated value for low, which is 4 plus 6, okay, that is 10. And then 10 divided by 2 is 5, okay. Now we have updated value for middle is 5, okay. And then on index 5, let's check what we have on index 5. 0 1 2 3 4 5. On index 5 we have 49, okay. So is 49 is equal to 41. That's incorrect, this line won't get executed. Now it comes back here is 49 less than is equal to 41. That's incorrect, and this line won't get executed, and our automatically our else block will get executed, okay. So here we have high is equal to middle minus 1, okay. So our middle value was 5, okay. So high is equal to middle minus 1, okay. 5 minus 1, that will become 4, okay. Now we have new value for high is 4, okay. Now it comes back here again. So we have high value and 4 becomes same, okay. So high values are 4. Is 4 less than is equal to 4? That's correct, okay. Then again this line will get executed. Low plus high, we already had low is 4, and now we have high value which got incremented in last iteration is 4, okay. And 4 plus 4 is equal to 8, but divided by 2 it will become 4 plus 4 8 divided by 2 it becomes 4, okay. Now middle is our 4, and then array middle, okay. What we have on fourth index in our array, we have 0 1 2 3 4. We have 41 on fourth index, okay. So here this line will check 41 is equal to target, which is it's a 41, so this will get executed, this line. So it will simply return the index, which is 4, okay. Middle elements 4. So that's how we completed the binary search algorithm stepwise, and we also covered the implementation and definition and iterations through the slides and through the code as well. So yeah, that's it guys, and you can also watch my previous video about the linear search, and we'll try to cover more of the data structures in the upcoming videos. So if you have any questions or doubts, you can write down me in comments, and I will catch you up in the next video. Bye guys, take care.